Everyone, good morning. I think my audible, right? There was some technical issue with the camera, so that's why I couldn't make time. Okay, so I think everything is visible now. So we'll start, right? So we'll start surface integral 0, 1. So in vector analysis, this is lecture number 9. So if you haven't watched the previous videos, so go through all the previous videos. So far what we did in a vector analysis is that, so first we have started with the gradient, divergence and curl. After that we have finished line integral. Now we are in surface integral, right? So this is similar to a line integral, right? So you just recall what is meant by line integral, right? So just recall what is meant by line integral. So I just take the PPT of line integral. This is the one that you already completed, right? This is the one you already completed. So we already discussed about what is meant by line integral, right? So any integral which is to be evaluated along the curve, right? So along the curve is called line integral. This is very important. So we are evaluating that integral along the curve. For example, if this is the curve C, right? If this is the curve C, so we are evaluating this. We are evaluating this integral over this curve C, right? So I have already explained this. So instead of this curve C, right? Instead of this curve C, we are going to evaluate over a surface S, right? So instead of this curve C, this curve C now is going to be a surface, right? So surface can be a sphere, or it can be a plane, or it can be a cylinder, it can be anything, right? So instead of this curve, right? Instead of this curve, this is a 1D, right? So we're going to evaluate the integral over a surface now. So instead of curve, they will give a surface, right? That is the only difference. So any integral which is to be evaluated along the curve is called an integral. Any integral which is to be evaluated along a surface is called surface integral, right? So we're going to define what is meant by surface integral first. After that, in this class, we're going to do 4 problems in this class, right? So we're going to do 4 problems in this class that is based on surface integral. Surface integral is very, very important. So maximum we will get 1 question in UPSC point of view, right? In UPSC point of view, there is a chance that 80% that we will get 1 question from surface integral. Okay, so first we will define surface integral and then we will solve 4 problems, right? So very easy, but you have to listen very carefully, right? Okay, surface integral. So any integral which is to be evaluated along a surface, right? Along a surface is called the surface integral, right? Is called surface integral, and it is given by double integral over S f vector dot n cap ds, right? This is the representation of surface integral. If f is a vector point function, right? If f is a vector point function, surface integral of f, the surface integral, the integration of f over the surface, right, is given by double integral over s f vector dot n cap ds, where n cap is the unit normal, unit vector in direction of unit vector in the direction of outward drawn normal to the surface, right? So don't think about this, right? So I'll let you know how to do the problem very, very easily. So the double integral, right? So double integral, any integral which is to be evaluated along the surface is called surface integral. it is given by double integral over s f vector dot n cap ds, right? Okay. Now the very important thing is the surface integral can be evaluated with the help of very important double integral. So it can be evaluated with the help of double integral integrated over a region R. This is very important. Integrated over a region R. Right? So very important. The surface integral can be evaluated with the help of double integral. Right? So we know how to evaluate double integral, right? So it can be evaluated with the help of double integral integrated over a region R with the help of double integral that is to be integrated over a region R, right? That means this can be evaluated double integral over S f vector dot n cap ds. So in exam point of view, they will just say f dot n. So they will not use vector here. They will not use cap here. So understand that whenever you have double integral over s f dot n or f vector dot n cap, you assume that it is surface integral, right? This can be evaluated over a region R, right? This can be evaluated over region R, and it is given by f vector dot n cap. Now there are three formulas to evaluate surface integral. You need to choose those formulas appropriately, right? Or appropriately, you need to choose which one you have to choose, right? I'm going to write down all those. So what is ds is? ds is a projection, right? ds is a projection, and ds is projection. Right? It seems to be it seems to be lightly vague, but no problem, right? Very simple. So f vector at n cap. So instead of ds, I'm going to project on xy plane. So dx dy divided by modulus of xy plane. So it will be n cap dot k vector. So you have to use this if you are projecting on xy plane, or you have to use this formula double integral over s f vector dot n cap. So we are projecting on this on xy plane. So dy dz divided by modulus of n cap dot I vector if you are projecting on yz plane, right? Or this can be also written or that is double integral over s f vector dot n cap ds. This is double integral over r f vector dot n cap yz zx plane, right? dz dx divided by modulus of n cap dot, you just see which is missing here, right? Dy is missing, so you put dot j. So this is projection on xy plane, projection on yz plane, projection on xy plane, projection on projection, that is you are projecting that surface, right? Projecting on yz plane. This is projection of xz plane, right? So you need to use any one of these three formulas to evaluate this surface integral, right? So whenever you are using this formula, you need to pick a formula, right? You need to pick a formula depending on the question, but it is very easy to pick, right? Whether you have to use this or this or this, I'll let you know how to do this, right? So you need to make sure we need to choose accordingly. All right, I write down this note. As of now, you just see this as a note, but I will let you know how to do when we are doing this problem. So we need to choose. We need to choose. We need to choose accordingly. We need to choose accordingly. As the surface, yes. As a surface, yes, should not be perpendicular. Should not be perpendicular to. Should not be perpendicular. Should not be perpendicular to the projection plane. To the projection plane. right? So you just you need to choose accordingly such that the surface S and the projecting plane should not be perpendicular, right? If it is perpendicular means then this integral will be 0, right? Okay. Okay. So any integral which is to be evaluated along a surface is, that is what I said in the beginning, right? In line integral, if you have seen line integral, you will use a curve C and you will get the output, right? So Shanga, I think you have joined late. So instead of this curve C, we are going to use surface integral, right? This is very, very hard to visualize the 3 dimension, right? Okay. Now we want to do the problem, right? So you need to choose this or this or this accordingly, right? Now I'll let you know how to choose which of them integral, right? I'll explain that in problem, right? So therefore, so double integral over S f vector dot n cap ds is double integral over R f vector dot n cap. So instead of ds dx dy divided by n cap dot k, or you can use anything, right? Now the important thing is what is n cap? So n cap is given by, very very important, where n cap is given by del del phi by modulus of del phi, where phi is the surface, where phi is the surface, right? So this is how you should choose n cap, very important, right? So n cap is del phi by modulus of del phi, where phi is the surface, right? They will give a surface yes, right? That yes, you take it as phi. You know del phi, right? What is del phi? It is gradient, right? It is gradient. So n cap, the formula for n cap is del phi by modulus of del phi, where phi is the surface, right? Okay, where phi is the surface. Okay, so we'll remember this very important note. So in order to find f vector at n cap, f vector will be given in the question, but they will not give n cap. So you should use n cap to be del phi by modulus of del p. That p is the surface that they are giving. So you just find the gradient for that surface divided by modulus of del phi, right? You know how to find gradient for a vector point function, right? It is dou phi by dou x I vector plus dou phi by dou y j vector plus dou phi by dou z k vector, right? Okay. We will recall what is meant by an octant, right? So an octant in a 2D, right? So in 2 dimension, we will have 4 quadrants, right? First quadrant, second quadrant, third quadrant, fourth quadrant. In first quadrant, you will like x and y are positive. In second quadrant, x is negative, y is positive. In third quadrant, x and y both are negative. In fourth quadrant, x is positive, y is negative, right? That you know. Similarly, for 3 dimension, instead of quadrants, we will say it as octant. So it has 8 octant, right? A 3 dimension plane will have 8 octants, right? So first octant, second octant, third octant, fourth 1, 2, 3, 4, and in bottom there will be 5, 6, 7, 8, right? So there are 8 octants in a 3 dimensional system, and you just remember this, in first octant all are positive, that is x y z all are positive, right? So as of now you just remember only this, in first octant x y z all are positive, right? In first octant 99% of problem will be based on the first octant. So in first octant x is positive, y is positive, z is positive, right? Okay. So as of now, what we have seen is we have introduced the definition of a surface integral, that is double integral over S f vector dot n cap ds. This S can be evaluated over a region R by using double integral. So you need to choose ds accordingly. So ds is dx dy by n cap k, or dy dz by modulus of n cap dot I, or dz dx divided by modulus of n cap dot j. So you need to choose this accordingly, right? Okay. And what is n cap? N cap is del phi with modulus of del phi, where phi is the given surface. Right? So we'll straight away get into the problem. Right? So we'll straight away get into the problem. Evaluate double integral over S f vector dot n cap ds, where f vector is given by yz I vector plus zx j vector plus xy k vector, and s is the part of the surface of the sphere x square plus y square plus z square is equal to 1, which lies in first octant, right? So we have f. So f is yz I vector plus zx j vector plus xy k vector. And what is the surface here? The surface here is the sphere x square plus y square plus z square is equal to 1. A sphere of radius 1. Because if it is r square means it is the equation of sphere with the center 0, 0, 0. So here we have r to be equal to 1. Radius is 1. So it is a sphere with the center at origin and the radius is equal to 1. We need to evaluate this over the sphere which lies in the first octant, right? So it has to be in the first octant, right? It has to be in the first octant. We need to find that, right? Okay. Solution. Very easy problem. So we need to evaluate double integral over s f vector dot n cap ds, right? F vector dot n cap ds. So ds can be what? Ds can be any of these three, right? Any of these three, we need to choose accordingly. I'll tell you how. Very easy, right? Very easy to very easy to find which is very easy to find whether we need to choose this or this, right? Okay. Now before that we will find n cap, right? Because we need n cap. Now here, what is the surface they have given? You take that as phi. Because to find n cap, we need del phi by modulus of del phi. But phi is the surface. So here the phi is x square plus y square plus z square minus 1. Now you find del phi. What is del phi? It is dou phi by dou x I vector plus dou phi by dou y j vector plus dou phi by dou z k vector. So dou phi by dou x I vector. So it will be 2x I vector, 2y j vector, 2z k vector, right? So if I take this 2 outside, we have xi plus yj plus zk. Now modulus, what is modulus of del phi? It is square root of, okay, let us keep this as it is. Now we just find modulus of del phi. This implies what is modulus of del phi? So it will be square root of 2x whole square, 2y whole square, 2az whole square. Now if I take 4 outside, because 2 square is 4, we will have x square plus y square plus z square. Now I can use x square plus y square plus z square to be equal to 1. So this will be 4 into 1. This will be 2, right? So modulus of del phi is 2. Now what is n cap? So n cap is del phi by modulus of del phi, where phi is the surface. So del phi is 2x I vector, 2y j vector, 2z k vector divided by 2. So if I take this 2 outside, we will have xi vector plus yj vector plus zk vector. This is the n cap. Now we will find f vector dot n cap. Right now we will find f vector dot n cap. F vector dot n cap. So f vector is this, n cap is this. You just make a dot product, right? So just make a dot product. So f vector is yz I vector plus zx j vector plus xy k vector dot. What is n cap? It is xi vector plus yj vector plus zk vector, right? So I'm using x square plus y square plus z square is equal to 1. So to make a dot product, you will have x into yz is xyz, zx into y is again xyz, xy into z is again xyz. So therefore 3 times xyz is f vector dot n cap. So whatever before choosing ds, right? Before choosing ds, you just find f vector dot n cap. But this is very easy to find, right? So you just take the surface to be equal to phi. find del phi by modulus of del p, which is n cap, and make a dot product with f. You will have f vector dot n cap ds. Now what we going to choose? Ds, right? Okay, now I'm going to choose ds to be dx dy divided by n cap k. That is, we are projecting on xy plane, right? On xy plane. Now double integral over s f vector dot n cap ds. This will be double integral over r f vector dot n cap dx dy divided by n cap k, right? N cap, this n cap dot k. I'm projecting on xy plane. You can also project this on yz plane also, right? First we will do this and then I'll let you know how you can do the others also. So f vector dot n cap dx dy divided by modulus of n cap k. Now what is modulus of n cap k? Now what is modulus of n cap dot k vector? Do you know what is n cap? So n cap is xi plus yj plus nk dot. You need to make a dot product with k vector and you take modulus. So if you make a dot product with this, you will have what? Xi plus yj plus zk dot k. So it will be z, right? So we will have only z here. We will have only z here. Very simple, right? So modulus of n cap dot k, n cap is no k vector. Just make a dot product with k vector. So this is 0 I plus 0 j plus 1k. So z into 1. So you will have z. So therefore, this will be double integral over r. What is f vector dot n cap? F vector dot n cap is 3xyz, right? 3xyz is f vector dot n cap dx dy divided by n cap dot k is z. So this z will get cancelled. So this will be double integral over r 3xyz dx dy, right? Now we need to choose x limits and y limits, right? We need to choose x side. It's 3xy dx dy. Now we need to find x limit and the y limits, right? Now we need to choose the limits, x limits and y limits with the help of the surface, right? Now what's the given surface? What is the given surface? It is x square plus y square plus z square is equal to 1. We are projecting on xy plane. So since on xy plane z is always 0, right? On xy plane z is 0. So if you are projecting on yz plane, your x will be 0. If you are projecting on zx plane, your y will be 0, right? On xy plane z is 0. So therefore this now turns out to be a circle, right? This now turns out to be a circle with the center 0 0, radius 1. So that means we need to choose dx dy, right? Okay. That means what is x square is 1 minus y square. So x is equal to plus or minus root of 1 minus y square. So since we need to evaluate on first octant, in first octant we know everything is positive. This implies x varies from 0 to root of 1 minus y square, right? So since we are in first octant, you take from 0 to root of 1 minus y square, because we know in first octant all are positive. So x varies from 0 to root of 1 minus y square. And where y varies, if you are choosing one as a variable, you need to choose others as some numbers, right? And also you can see y varies from 0 to 1, right? Because it's a circle, right? It is a circle. So it's a circle with the center 0 0, radius 1. So y varies from 0 to 1. Or if you want to choose y limits, you put x is equal to 0, right? So put x is equal to 0. You will get y to be equal to plus or minus 1. So since we are in first octant, y varies from 0 to 1. So you choose something as variable, others has both to be numbers. You can also choose y to be root of 1 minus x square and x varies from 0 to 1. You can also do like that also, right? Okay, you can also choose y to be varies from 0 to root of 1 minus x square, x to be varies from 0 to 1. You can choose anything, right? So this is the limits now. So to find limit, if you are choosing projection on xy plane, put z is equal to 0. So you will have in terms of xy, you write one limit as a variable, the other limit as both to be numbers, right? Is it clear? Okay. So therefore, this now will be integration of, so we have y, so y varies from 0 to 1, y varies from 0 to 1, x varies from 0 to root of 1 minus y square, dxy dx dy. So we are choosing this since we are in first octant, since we are given first octant, right? Okay. So just evaluate this. So y varies from 0 to 1 with respect to x. So 3y is constant. Integration of x dx is x square by 2. So 0 to root of 1 minus y square dy. So this will be 3 by 2 integration of 0 to 1 y into, so x square will be 1 minus y square, right? So root of 1 minus y square whole square into dy. So this will be 3 by 2 integration of 0 to 1 y minus y cube dy. So this will be 3 by 2. So integration of y dy is y square by 2. This will be y power 4 by 4, 0 to 1. So 3 by 2, 1 by 2 minus 1 by 4, right? Upper limit minus lower limit. So 3 by 2, so into 2 into 2. So 2 minus 1 by 4. So this will be 3 by 8, right? So 3 by 8 is the required integral. Is it clear? Very simple, right? So suppose if you are taking if suppose instead of dx, instead of taking dx to be dx dy divided by n cap k, if you are choosing we are choosing xy plane, right? Projecting on xy plane. If you are choosing y z plane, you just put x to be equal to 0. You will have y square plus z square to be equal to 1. You take one as variable, other as 0 to 1. You get the same answer only. I think you are following, right? If you are choosing xy plane means, sorry, if you are taking zx plane means you take y to be equal to 0. You will have x square plus z square to be equal to 1. You put z is equal to, you vary z to be from 0 to root of 1 minus x square. X varies from 0 to 1. You will get the same answer only. Is it clear? Or I want to repeat. I'm waiting for a comment. This y, right? Root of 1 minus y. Is it clear? Or I need to repeat? No. In this problem we can choose anyone, but it is not for all the case, right? I let you know. In this problem for sphere you can choose like this. That is, you need to choose accordingly, as that the surface S should not be perpendicular to projecting plane. That is, the surface dot projection plane should not be, you know how to find angle between two surfaces, right? So that angle between two surfaces should not be 90 degree, right? Projection, if you are choosing xy plane means z is equal to 0. That is, z is equal to 0 is your surface. Now you find angle between the given surface and z is equal to 0. If this is not 90 degree means you can choose that. If it is equal to 90 degree means you should not choose, right? Okay. So we move on to second. When we do 2 or 3 problems, you know how to choose, right? Okay. So I'm going to, we will choose. I'll do this. So evaluate double integral over s f vector dot n cap ds, where f is z I vector xk vector minus 3y square k vector 3y square z k vector, and s is this, and s is the surface of the cylinder x square plus y square is equal to 16, included in the question itself. You can but from the question itself you can decide which one to choose. In the first octant between z is equal to 0 and z is equal to 5. Now from the question itself you can see they are given z limits, right? Actually the finding limits is difficult in surface integral, so they are given the z limits. So you can project that on xz plane or yz plane, right? The problem will be very easy. So since we know z limits, where you will have z, here you will have dy dz, here you have dz dx. So you choose any one of these two, right? Because we can directly put z varies from 0 to 4, and here also you can directly put z varies from 0 to, what is the given, 0 to 5. So you can directly put z varies from 0 to 5. Z varies from 0 to 5. The only thing is you need to find the limits of y or x, which one you are choosing. But if you are, you cannot, but if you are choosing this, the problem will be very big when compared to these two. So it is recommended to choose any one of these two, as we know the z limits, right? So I'm going to choose any one of these two. So I'm going to choose, you can choose any one of these two, and you choose which integral is easy to evaluate, right? Okay, I'll let you know how to do. So I'm going to choose I'm going to choose this, right? Dy dz divided by n cap dot I, the solution. So before that, we will find f vector dot n cap. So what is n cap? So n cap is del phi by modulus of del phi. So here, what is the surface here? So it is x square plus y square minus 16. So what is del phi? So I write directly. Okay. So dou phi by dou x I vector plus dou phi by dou y j vector, dou phi by dou z k vector. So this will be 2x I vector, 2y j vector, right? So what is modulus of del phi? So it is root of 4x square plus 4y square. So if I take 4 outside, we will have x square plus y square, and we know x square plus y square is 16. This will be 4 into 16. So root 64 is 8, right? Root 64 is 8. It will be 4 into 16. Okay. So what will be n cap? So this implies our n cap is 2x I vector, 2y j vector divided by 8, or this is xi vector plus yj vector by 4, right? We take 2 outside. So now we will find f vector dot n cap. So f vector is zi vector plus xj vector minus 3y square z k vector dot n cap. So n cap is xi plus yj divided by 4. So if I take this 1 by 4 outside, it will be xz plus xy j vector, right? Xz plus xy k vector. This is our f vector dot n cap. Now I'm going to choose ds to be, since we know z limits, I'm going to choose dz to be dy dz. Therefore, double integral over s f vector dot n cap ds. This will be double integral over r f vector dot n cap dy dz divided by n cap yz. So it will be n cap dot I, right? N cap dot I. So this will be double integral over r. What is f vector dot n cap? So we have already found f vector dot n cap. So sorry, here we don't have a j. So 1 by 4 xz plus xy. Okay, so 1 by 4 xz plus xy dy dz, right? Xz plus xy dy dz divided by, so what is n cap, sorry, this n cap dot I. So n cap dot I, so this is n cap. If you make a dot product with I vector, you will have x by 4, right? You will have x by 4. Is it clear? Make a dot product with n cap I, we will have this to be x by 4. I'm not writing this, right? This is n cap xi plus yj. Make a dot product with I vector, we will have x by 4. Okay. Now this, I can take this x outside and I can cancel this x. And if I take this 4 and I can cancel this 4 and this 4. So we will have double integral over r y plus z dy dz, right? And we know we are the surface. So surface here is we need to find the limits now. X square plus y square plus 16. We know z varies from 0 to 5. And since we are in a yz plane, on yz plane x is 0, right? This implies y square is equal to 16, and this implies y is equal to plus or minus 4, and we are evaluating first octant, so that means y varies from 0 to 4. So therefore this integral will be integral of z varies from 0 to 5, z varies from 0 to 5, y varies from 0 to 4, y plus z dy dz, right? So this will be integration of z varies from 0 to 5. So this will be y square by 2 plus zy 0 to 4 into dz. So this will be 0 to 5. So when you put upper limit, 4 square is 16. So 16 by 2 plus 4 is dz. So this will be 8, right? Will be integration of 0 to 5. 8 plus 4 is dz will be 8. Integration of dz is z 0 to 4 plus 4 times z square by 2 0 to 5. So this will be 40. This will be 2 into 25. It will be 40 plus 50. 90 is the required answer, right? Now suppose if you are choosing instead of d, I have said that you can choose any one of these two since you know z limits. Suppose if you are choosing this ds, right? Suppose if you are choosing dx dz. Suppose if you are choosing this means, that is if you are choosing f vector dot n cap dx dz divided by n cap j. So we know f vector dot n cap is what? So it is f vector dot n cap is, okay, sorry. So suppose if you are choosing f vector dot n cap dx dz divided by n cap dot j. I have said that you can choose any one of these two, right? Suppose if you are choosing this, what is f vector dot n cap? It is 1 by 4 xz plus xy and dx dz divided by n cap dot j. N cap. So n cap dot j. So n cap is this. If you make a dot product with j, you will have y by 4. You will have y by 4. You will have y by 4, right? The only thing is you can see the y's are not cancelling here. But if you take that, the integration is very easy to perform, right? You can also do this integration also, but it will take so much of time to integrate this, right? So this 1 by 4 will get cancelled. So this will be xz plus xy. You will have y here, right? You will have y here. This we cannot take this y common and we cannot take cancel this y. But in that case, you have cancelled that x, right? Okay, if we are okay, let us, if you want to keep it this, if you want to keep like this itself, right? xz plus xy divided by dx was this y by 4, right? Okay. So suppose if you are keeping this itself means we are given the plane. So if you can choose any one, but if you are choosing this means the integration will be difficult. We are given x square plus y square. What is that? X square plus y square is equal to 16, right? So what you need to do is on xz plane, your y is 0, right? Your y is 0. So x varies from 0 to 4, right? And similarly, z varies from 0 to 5. Here you will have by y, right? That's the only difference. You do this, right? You do this, you will get an idea, right? Okay. So here we have by y. So this will be like this. Then move on to third problem. You will. So from question itself, you can see whether which one to choose ds, right? So the third problem. Here the only difference is only difficulty here, that is if you are choosing the other, right? Sorry, I'm erased. Suppose if you are choosing, the only difficulty here is what is f vector dot n cap. The only difficulty that is we have to, here we are choosing dy dz, right? Instead of choosing this, suppose if you have chosen this means the only difficulty what we will have is if we know f vector dot n cap is 1 by 4 xz plus xy dx dz divided by n cap j is y by 4. Now we are integrating with dx dz, right? So here everything should be in terms of you can see dy dz, everything should be in terms of y and z, right? Everything should be in terms of y and z. But if we are integrating this with this means we should have everything in terms of xz, but we have y is here, right? That means we need to convert y in terms of x, right? So we know x square plus y square is 16. So that means y will be y square is 16 minus x square. That means y, since we are in first octant, y is root of 16 minus x square. So therefore now this integral will be, so we know z varies from 0 to 5, y varies from 0 to 4 only, right? So for on a xz plane where y is 0, so therefore x square is 16. So since we are in first octant, it will be 0 to 4. Now this 1 by 4, 1 by 4 will get cancelled. So if I divide this y individually, xz by y and this yy will get cancelled into xy dx dz. So this will be integration xz divided by y is root of 16 minus x square plus x into dx dz. Now you need to integrate this, right? Now you itself see which one is easy to integrate. This integral we can integrate this, but it will take so much time when compared to this integral, right? So if you are choosing the projection on yz plane, you are getting y plus z dy dz, which is very easy to integrate. But if you are choosing this means you can choose this, but you can see you need to integrate xz divided by root of 16 minus x square plus x dx dz. You are going to get the same answer only, but it will take lot of time when compared to integrating double integral over r y plus z dy dz, right? So that's why only I'm taking this projection on dy dz by n cap dot I instead of n cap dot j. Is it clear? See, if you are integrating this also, you're going to get the same answer only. But when compared to this is very easy to perform. So I'm taking this. Okay. We'll move on to third problem. So evaluate double integral over S f vector at n cap ds, where f is y into I vector plus 2x j vector minus zk vector, and S is the surface of the plane. S is the surface of the plane. Now here we have chosen since they are given z limits. I have said that you choose this or this, but no one have asked why we should not choose this, right? If you choose this, you find the angle between xy plane and this surface. You will get that both are perpendicular, right? You know how to find angle between the two surfaces, right? And we already said. So for a xy plane, the equation is z is equal to 0. Suppose if you are choosing this means you cannot choose this, right? You cannot choose this. If you are choosing this means xy plane and the surface will be perpendicular. In this case, we should choose accordingly. That surface should not be perpendicular to that plane. But if you are choosing this, I have said that since they are given z limits, you choose this or this. But you cannot choose this, because if you choose this, the surface yes will be perpendicular to xy plane in this case. That is why we should not choose this, right? So evaluate, and S is the surface of the plane 2x plus y is equal to 6. In the first octant, cut off by the plane, cut off by the plane, that is equal to 4. Again, you can see in the first octant they are given it is cut off by the plane z is equal to 4. That means z varies from 0 to 4 since we are in first octant. So we know z limits. That means what? You need to choose this or this, dy dz or dx dz, right? Dx dz, or you can also write as dx dz, right? No problem. Both are same only, right? So you need to choose this or this, right? So since we know z limits, now you can choose this or this. You see which integration is easy to perform. You perform that integral to evaluate the answer, right? Okay. But you cannot choose this xy plane. That is, we cannot choose projection on xy plane. If you are choosing this means you will get both to be perpendicular in this case, right? Okay. So very simple, right? You just find angle between the two surfaces. This is the first surface, the other surface is z is equal to 0. So you know angle between two surfaces, right? Okay. Find that you will get cos theta is equal to 0. Okay. What is angle between two surfaces? Cos theta is equal to del phi 1 dot del phi 2 divided by modulus of del phi 1 into modulus of del phi 2, right? Okay. Again, we will first what is the surface here? Surface here is 2x plus y minus 6. Now we will find del phi. So del phi will be dou phi by dou x I vector plus dou phi by dou y j vector plus dou phi by dou z k vector. So dou phi by dou x, so it will be 2y vector. Dou phi by dou y will be 1. So it will be j vector, and this will be 0, right? Because there is no k. This is del phi. Now modulus of del phi, it is root of 2 square plus 1 square. It will be root 5. So therefore, n cap is del phi by modulus of del phi. So 2I plus j vector divided by root 5 is our n cap. Now, what is f vector dot n cap? So f vector is y into I vector plus 2x into j vector minus z into k vector dot n cap is 2i vector plus j vector by root 5. So if I take this 1 by root 5 outside, so we will have 2y plus 2x, right? 2y plus 2x. So if I take this 2 outside, so 2 by root 5 x plus y, right? So 2y plus 2x. So 2 by root 5. So therefore, double integral over s f vector dot n cap ds is double integral over r f vector dot n cap. So I'm going to choose dx dz divided by n cap dot j. You can also choose dy dz also, right? The previous problem we have chosen dy dz, right? I'll do both, right? I'll do both. So this will be double integral over r. What is f vector dot n cap? So we can choose either dy dz or dx dz, right? Okay. So what is f vector dot n cap? So it is 2 by root 5. It is 2 by root 5 x plus y, right? 2 by root y x plus y dx dz. Now what is n cap dot j? N cap. So what is n cap? N cap dot j. So n cap is this. Make a dot product with j. You will have 1 by root 5. Right? You will have 1 by root 5. This 1 by root 5, 1 by root 5 will get cancelled. So we will have 2 integral over r x plus y dx dz, right? So on the surface, what is surface? 2x plus y is equal to 6. We know z varies from, so we know z varies from 0 to 4, right? Z varies from 0 to 4. Z varies from 0 to 4. On xz plane, y is 0, right? On xz plane, y is 0. Therefore, 2x is equal to 6. That means x will be 3. So since we are in first octant, yes, x varies from 0 to 3, right? Suppose if you are choosing dy dz means, you are if you are choosing dy dz means your x will be 0. In that case, y varies from 0 to 6, right? Okay. So 2 times integration of z varies from 0 to 4, right? 0 to 4. Z varies from 0 to 4. Z varies from 0 to 4. X varies from 0 to 3. X varies from 0 to 3. X plus y dx dz, right? So 2 times integration of 0 to 4. So this will be x square by 2 plus yx. X square by 2 plus yx 0 to 3 dz. So 2 times integration of 0 to 4. So 3 square. So 9 by 2 plus. Okay, wait. So dx dz, right? Sorry. So here everything should be in terms of xz, right? Sorry. Wait a minute. Forgot to convert that. Like we did in here, right? Like we did here. So if you are performing dx dz means everything should be in terms of xz. So therefore we have written y in terms of x. Right, here also we should convert in terms everything in terms of xz. That means we need to convert y, right? So we need to convert y. So this in here we can convert y to be equal to 6 minus 2x. Therefore this will be 2 times integration of 0 to 4, integration of 0 to 3, and y is 6 minus 2x dx dz, right? Y is 6 minus 2x dx dz, and this is 2 times integral 0 to 4, integral 0 to 3, 6 minus x, right? X minus 2x is x dx dz. So this will be 2 times integral 0 to 4, integral 0 to 3, 6 minus x dx dz. So integral 0 to 4, 6x minus x square by 2, right? Integrate with respect to x, 0 to 3 dz. So this will be integral 0 to 4, 6 3s are 18, 3 square is 9, so it will be 9 by 2 into dz. So this everything is constant. So 2 into integral of 0 to 4, 36 minus 9 by 2 dz. So 2, I take this 2, I can cancel this 2. So 36 minus 9 is 27, right? So 27 integration of dz 0 to 4. So this will be 27 into 4. 27 into 27 into 4 is the required answer. So 27 into 4 is what? 108, right? 108. You can also choose dy dz also, right? Okay, I'll do here. I'll it here. So instead of this, you can also choose f vector dot n cap dy dz by n cap I, right? N cap I. So this is f vector dot n cap is 2 by root 5 x plus y dy dz divided by n cap dot I. So n cap dot I is 2 by root 5. So this will get cancelled. So we will have x plus y dy dz. So everything should be in terms of yz. That means we need to convert x in terms of yz. So you can convert x in terms of yz, right? So we have 2x plus y is equal to 6. So 2x is equal to 6 minus y. So x is equal to 6 minus y by 2. So this will be 6 minus y by 2 plus y dy dz. So this will be double integral. So the cross multiply this 2y minus y is y. So it will be 6 plus y by 2 dy dz. So we know z varies from 0 to 4. To find y limits, so we are in yz plane. On yz plane, z is 0, right? On yz plane, yeah, sorry, x is 0. So that means y will be 6. So y varies from 0 to 6. To evaluate this integral, you will get the same answer as 108. You get the same answer as 108. Is it clear? See, you can choose dx dz by n cap dot j or n cap dot I also. So if you are having dy dz means here everything should be in terms of yz, but here x here. So convert x in terms of yz with the help of the surface. So you will have everything in terms of yz now. Here z is, there is no z term here, no problem. So integrate over dy dz, find y limit and z limit. So we know z varies from 0 to 4. And for y limit, so since we are in yz plane, x will be 0. So y varies from 0 to 6 since we are in first octant, right? So integrate over this, you will get the same answer as 108. Right? So we'll do one more problem. Here you can note, right? Here you cannot choose xy plane. You can either choose dx dz or dy dz, but you cannot choose xy plane. If you are choosing xy plane, you will get you will get it should be noted that it should be noted that in this case we cannot take the projection. In this case we cannot take the projection on xy plane because the surface yes, because surface yes is perpendicular to xy plane, right? You find the equation of xy plane. So equation of xy plane and surface is this. You just find the angle between two surfaces. You will get 90 degree, right? Perpendicular means angle between them is 90. Sorry, at one time I have said it is equal to 0, right? Yes, cos theta will be 0 means theta will be 90 degree, right? Okay. So cos theta is del phi1 dot del phi2 by modulus of del phi1 into modulus of del phi2. That is the angle between two surfaces. You will get 0. That is cos theta has to be equal to 0. That means both are perpendicular, right? Okay. So we'll move on to last problem in this class. So evaluate double integral over s f vector dot n cap ds, where f is 18z I vector minus 12j vector. So when if you are doing 10 to 15 problems, then these problems are very easy. You can do very fast. Dy k vector, and s is the part of the plane, and s is the part of the plane, 2x plus 3y plus 6z is equal to 12, which is in the first arc. So we'll do this very fast. So what is surface here? The surface here is 2x there is power of here. I forgot to save the PPT also. Forgot to save that annotation, so everything annotation is lost. Okay, no problem, I can get that from video. So we'll do this problem, right? So I think everything is visible, right? The camera is not visible. Okay, so we'll stop here. So the next class we will do that fourth problem, right? So we'll stop here. So I think camera is not visible. So we'll stop here. Next class we will continue the remaining problems, right? So we have finished 3 problems on surface integral. So the next class we will do the fourth problem, and then we'll continue surface integral, right? So if you have any doubt, you can ask, or else we'll wind off. So you try to do the fourth problem. I will continue with the fourth problem in the next class, right? Okay. So thank you. Bye.